Same. At least you saved me now. That's fine. But why I'm forgetting
Because
this?
Vamsi bhai, I didn't find the recording icon on the left hand side. That's why I just prompted you.
Thanks a lot. Thanks a lot. At least now we can say. Of course, we didn't progress much. We just started our class. I was just saying that we cannot decrypt the data without having CMK. That's the only part what we are saying. Even if you use the connection string, it doesn't matter. We don't have the keys with me. I don't have the CMK with me. So even any hackers, if they wanted to hack my data, they can't do it because that certificate will be there only on the right servers, app servers or web servers, whatever it is. So if you are doing it on web servers, then how to you have to create it on that web server, and who should have access to that keys then? That is the question, right? In real time, this looks, I mean, in the development environment like this, it's very easy to say. But when you are doing this in real time, there are a lot of challenges here. It's not that easy thing to implement always encrypted. There are so many setbacks or limitations, right? That is one thing. Second thing, how to provide access to the certificate and who should have access, who should have permissions on this certificate. That is also one more thing. So these are all the challenges what we have when it comes to always encrypted. Now imagine this app server or the VM, whatever what I have, imagine treat this as an app or web server. And if I wanted to access this data, I should have the CMK. So where is my CMK? My CMK is on my local laptop. So what should I do? I have to export this. Come here, all tasks. So export. I have to export this certificate and then I have to copy that certificate. If you want to export it with the private key, you can do it. If you don't want, you can say no, I don't want. If you do export the private key, the benefit is you can set the password. So if you can set it the password also, so you will be more secure. So I'm setting one password for this. And I have to export this certificate onto the missions where I wanted to see the unencrypted data. Otherwise, it will not work. So I will say some d:temp. Oh, I already have this. Not this one. I will use this one. I will say CMK. Finish. So now my certificate has been exported. If I wanted to get the data, then I have to copy that. So d:app. This is the certificate. Copy this onto this mission. So come here and paste it into one of the drives. Okay. I'll use some other drive. f:log. I'm pasting it here. Now I have to import this certificate. Come here, alt task, import. Click on next. So when you are importing, there is one thing you have to watch out. Alt task, import. If you're doing it, so there are two options. Current user, only that user will be able to see the data, and the other one is local mission. So if you set it to local mission, anyone who connects to this mission will be able to access the data. So be very careful when you are doing. This is just a test environment, so I'm using current user, but in real time it has to be local mission. So careful about that part and give that information to SQL, I mean certificates. So why I'm not getting, I'll say all files, CMK. Okay, click on next. I have to pass on the same password what I have set when I'm exporting. Certificate store. So I'm keeping this under personal. And now click on finish. So it's successful now. So now if I open, I have this certificate, always encrypted certificate. So now if I try to run this query, same query, I'm getting the results. So that's the beauty of always encrypted. Only the users who wants to really see this data, they can only have that certificate with them. That is CMK certificate. So even DBS, if they don't have the CMKs, it's not possible for DBS to see the unencrypted data. Forget about DBS, even SQL Server itself doesn't know how to get the data. Okay, so when I say SQL Server means DB server. We have SQL running on our DB server, right? I'm talking about the VMs now, not about Azure SQL or Azure MI. So even if I install it, I mean, if I do this on Azure VM or on premises, so that is a DB server where DB engine is running. So DB engine itself, if it doesn't have CMK, it cannot get the unencrypted data. It's not possible for even for SQL Server also. If SQL Server itself is not able to do, for then imagine our situation as a DBA, we cannot do it. So CMK is the critical thing here. Whomever possesses that CMK, they will be only able to watch the data. Rest of the people, they can't do it. That is the funda of Always Encrypted. Now,
Vamsi,
yeah,
sorry to interrupt. Is it possible to modify the encrypted data?
means update the data.
Yeah, like see, somebody executed select a statement. They got some data, and he's having or she is having edit permission. Is it possible they can modify the data?
If he wants to modify, first of all, they should have CMK. That is first thing. Okay. Without CMK, they can't do it. Second thing is, if they wanted to modify also, they have to use the connection string like this one. These two things are super duper important when you are doing with Always Encrypted. This has to be there to do anything. Even to select the data, insert, update, delete, whatever it is, you have to have CMK, you have to have your column encryption setting enabled. Otherwise, it will not work. So coming to modification of data. So someone wants to modify this data. Okay, so imagine I wanted to delete the second row. So if I do something like delete from a table where ID equal to 2, I'll say where ID equal to 2. Let's see what happens. So I'm able to do this because I am accessing the data on non encrypted column. ID is not an encrypted column. It is an identity column. So I am able to delete the data. Okay. So if I wanted to insert the data, like in our last class, if I wanted to insert the data, see what happens. Values Smith. Smith is the last name. Steve Smith, right? If I do, it will throw an error. So even if I wanted to do an insert, you have to have the strong data type. What is the data type? You have to watch out for that also. So let me show you. Tables, which this one. So script out that. What is the data type for that column? You have to pass that as a variable. Just give me a second. I've changed everything to basic, I guess. So everything is super slow. Declare last name. Okay. So it has to be something like this. Declare last name. The data type has to match this one. It has to be nvarchar. Nvarchar 50 and variable name, I think declare. Why I'm getting this? It's because of this. Nvarchar. What is that? Declare last name nvarchar. It's not a recognized cursor option. What is cursor option? Oh, okay. Declaring a variable and I'm thinking, oh, what is error? First name, it has to be the same data type, nvarchar 50. So if I do like this, then I have to pass the values for this. So I will say nvarchar 50 last name equal to Steve and first name equal to Smith. If you get that underlines, what you are seeing that blue underlines, it's fine. No, there will not be any errors with that. It's because of this option inside the tools. When you go to the options, we have something called as text editor, general, not here. There is some option. Let me show you where is that. Related to Always Encrypted. That is why you are seeing that blue lines. It's not an error. That's how it behaves. I'll check this option. I think somewhere it is here. I think here only, I guess.
Query
execution. Advanced. Yeah, advanced here. So enable parameterization for Always Encrypted. Because of this option, you are getting that blue lines. So now if I say insert encrypted table name, what is it? Last name and first name. Values are last name and first name. Like I have to pass the variables last name and first name. Now if I execute this, then my rows get inserted and I will be able to see the data. I deleted the second row since we are having identity column. This is now appearing as third row. You know about identity columns, right? It follows the increasing order. If you delete that, that row will be gone. And it follows from the next step. If you wanted to have that proper order, you have to reseed that. So this is about always encrypt. I mean the basics. So someone was asking me like how to insert the data like multiple rows. If I wanted to insert multiple rows, what is my option? So that was the question. And we have to go with either .NET. I mean, from the front end, they will insert the data, right? It's not we who are going to perform inserts. If that is the case, they have to come up from the front end. So they will do it from their end. If I wanted to do, then I have to write a small kind of loop, which I think I've seen somewhere. Just give me a second. Insert something. If I wanted to do like this, it is not working, guys. This methodology is not working. I've seen some .NET code. I tried to do that. I got some errors, but as I said, I'm not good at .NET. What is that? It is like this only. I've seen some .NET code. I can do like this, or else we can do something like this. So from PowerShell, you have to have this kind of code, and we can set our data. So we can go with the loop option here, and we can do this. That is one more option. If I wanted to insert multiple rows into our table. So as I said, this is not a cakewalk. There are so many things that you have to observe. So if you are trying to suggest always encrypted in your environments, be very careful. Do the exercises a lot. Keep your hands dirty. Do many things. Then only you will be able to do this. It's not that easy. Just like TD. TD, it's just 4 steps, right? Come there and enable the master key and enable the encryption. It works instantly. But here, that is not the case. You have to be watchful with the limitations. And if you have such limitations, you have to pass that information to your developer saying that these things will not work. So as I said, very, very important thing is default constraints and check constraints. On that column, it will not work. I have listed this out. So these are all the things. All these things will not work. Even you can't do like comparisons, you can't do order bys, you can't do range queries. It's not possible. If you're having such things, don't go with always encrypted on that particular column. I'm talking about that particular column because we are doing always encrypted on columns only, not on the entire database. Okay, so that is the difference. And if you are going with randomized encryption, you can't do even these things also. Even the joins also not possible. So just imagine. So randomized, you can't do anything. You can't do any action on SQL Server. It's just to create that encryption. That's it. You can't do anything. But for deterministic, you can do joins, you can do group bys, but you cannot do order by on that particular column. You cannot do like on that particular column. And you have certain limitations like check constraint, default constraints. If you have CDC, DM, dynamic data masking, then you can't enable, I mean, you can't work with always encrypted. These are all the setbacks or limitations when you are dealing with always encrypted. Please go ahead with your questions. I'll take questions now. No, you are. I'm not able to hear you. No.
Hear now?
Yeah.
Okay. If we go back a little bit like this, so when we are exporting, so we are exporting to the local drive and then copy from to that drive where we want to send to the destination.
Yeah.
And then import from the destination to the same drive.
Yes.
Okay. That's it.
So thing is that, as I told you, since we are using Windows Store as the technology for storing the certificates, these are the things that you have to do. You have to export that, you have to import it if you wanted to access that data. If you are going with Azure Key Vault, it's a different story. The way you are operating with Azure Key Vault is different. I wanted to keep that as a last thing. So that's why I'm not showing Azure Key Vault for the moment. because even I have to go through that Azure Key Vault to get some hands-on. So I'm keeping it aside. But if you're doing with Azure Key Vault, you don't need to follow all the steps, because where you are storing the certificate matters most. If you are doing it in Azure Key Vault, the way you are going to access the data, I mean, the way you are doing the steps like import, export, it needs to be done. And then if you're going with HSM, HSM stands for Hardware Security Key Module. If that is the case, it's completely hardware stuff. I don't know much about it. Maybe it will be different also. So what we are using is only certificates, Windows Store certificate technology. So again, if someone asks you how to get the always encrypted data, remember you should have CMK. Without CMK, you can't do anything. And you should always enable this connection string. Without enabling this connection string, it will not work. Even though if you have the certificate, without that connection string, it will not allow you to get the data. So that connection string is column encryption setting equal to enabled. It has to be there. And now this topic itself is very difficult to understand. On top of it, so from SQL 2019, we have something called as always encrypted with security enclaves, which is very difficult to understand, very difficult to implement. Why these security enclaves? Even I understood, but I don't know how to teach this for you. So I will skip this topic. If you are interested, you can ask me personally, because it's very hard to understand. They're doing a lot of steps.
We don't want to stuck in that, because
Yeah.
confusing ourselves.
It will be confusing. So I'm just giving you a glance of always encrypted, how it gets carried out, and what are the limitations, and how to do it from basic side. That's enough for us to understand what is always encrypted. If anyone wants, let me know. Like if you have any questions, let me know. Not about always enclaves, always encrypted.
That column level encryption and always encryption. What is the difference?
There is so much difference when it comes to column level encryption and always encrypted, because in the column level encryption, we are using the regular certificates. Okay, so when I go with column level encryption, I will not use Azure SQL. I will use my machine. So if I go with any of the databases, for imagine DemoDB, if I go here and if I'm choosing one of the tables, I have, when it comes to security, I have something called as asymmetric key, certificate symmetric keys, right? So if I go with column level encryption, let us open column level encryption for a second. This is there even from 2005 also. I think from 2005 we have this. So for column level, I have some important information, some example bank account number. This has to be secured. So what I will do, these are the steps. Watch out these steps. It is completely different from always encrypted. So first we have to have database master key. So in always encrypted, did I say something like database master key? No, I said we have only two types of keys. One is column master key and the other one is column encryption key. Only two keys. Here it's a different story. This column level encryption needs database master key. So as I told you, this is the hierarchy. This is the hierarchy that we used to follow. So we have at the top layer, Windows operating system itself is protecting the service master key, SMK. So SMK gets created automatically when you install SQL Server. You need not do anything. SMK comes automatically as part of installation. And this SMK will be protected by service account and operating system access also. It's called as data protection API. I think I have explained this in my IAS classes. So this is SMK at the top, and at the bottom we have DMK. DMK stands for database master key, and database master key is the highest authority here inside this circle. And the database, under the database master key, we have certificates. We have the certificates, and again, after creating the certificate, you have to create symmetric key. So just I will show you a quick glance. So first step is inside the user database, we are creating the master key. This is database master key. Okay, this database master key will be encrypted by SMK, means service master key. So once we have created the DMK, the next step is creating the certificate inside the user database. So we are creating one certificate here. So once we have created the certificate, then we have to create the symmetric key for that column. So what we are doing is we are creating one more key called as symmetric key, and this symmetric key will be encrypted by certificate. So this is the hierarchy. As I told you, Just remember 4 steps. SMK at the top, and then inside the user database, DMK, and then certificate, and after that symmetric key. So symmetric key will be protected by certificate will be protected by DMK will be protected by SMK. This is the hierarchy for general column level encryption, not always encrypted, the regular stuff. So after creation of symmetric key, we are done, and now we have to implement this step. So whatever the column, what we want to do, that it has to be var binary max. Okay. So column level encryption, if you are doing it, it has to be a var binary data type. So var binary max. Okay. So you have to add that new column and then open that symmetric key using the certificate and update with this function. You will get that new encrypted data. Once you get that encrypted data, you can delete this old unencrypted data, and whomever possess that certificate, not certificate, if you wanted to access data, you have to open that using this command, open symmetric key, that key, and decryption by certificate. So the main problem here is all these things are being happened from our end, database end, on the DB server. Since we have access to all these keys, DBS can watch out this data happily. That is the problem. But in case of always encrypted, the encryption itself is happening at the application end or the client end. So CMK will be created by application team or the client team. If they are creating the CMK, since we don't have that CMK, we can't view that data, even though we are DBS. I mean sysadmin. That is the difference.
Yes, yes.
So entirely two different topics altogether. But if you ask me, if generally I will say column level encryption is good because we don't have too many limitations here. We can follow the steps, we can get the work done. But if you want more
Yes.
security and during the transit, if you want to safeguard your data, then we have to go with always encrypted. I don't think people are using that much as far as I know. But if there are any companies that wants to implement always encrypted, they have to understand the limitations like what I am showing it here. They have to ensure that those column is not identity column. It should not be having any user defined data types. The list is very big, right? So as you can see up to this. For deterministic, I'm talking about deterministic. For randomized, you just can't even go ahead with randomized because there are too many limitations. So you know the limitations and you know the difference now, right? So why they have come up with always enclaves? That is our next question. So if someone is coming with new technology, always remember, guys, till the last day of your day in your software field, if any new technology comes into picture, just ask yourself why. So as I told you, we have something called as always enclaves. So why always enclaves? What is the problem without having always encrypted? Why Microsoft has introduced that always encrypted is what you should know. I'm not going to talk about always enclaves. I'll just show you a glance. I mean, even to talk about that is very difficult because the topics are very difficult to understand. So I have written a small notes on it. I believe so. Let me check that part. Always. So this is what I wanted to talk about. So this is the diagram, guys. So always encrypted. Imagine he's searching for a single customer record. Result set with unencrypted data. Here you are seeing the credit card information. Why he is able to see the credit card information? Because this guy has column master key. Column master key is there on the client side. Imagine this is very important. CMK will be there on client side, not on the server side. Okay, so since he has this CMK, he is able to get the data. Whereas on the server side, everything is encrypted. Sensitive data remains encrypted inside SQL Server. If you see here, my credit card information is being encrypted. And on the server side, we have only column encryption key. So CMK will be there on client side. CEK will be there on server side. That you have to understand. I hope it is okay now. CMK always will be there on client side and CEK will be there on SQL Server side. Okay, the concept is client application and their owners control the encryption lifecycle here. See, it straight away says this thing. Client application and their owners control the encryption lifecycle. It is client that is being managing the keys. It's not DBS. Again, I'm saying it's not DBS. all the data is passed from client encryption, client application to SQL Server encrypted. So whatever the data that is getting from the client application, it is coming to SQL Server in encrypted format, stored in SQL Server encrypted at the column level, and sent back to the application encrypted. Everything, whatever the data that is coming to the SQL and coming back from the SQL is completely encrypted. You cannot see the data. Even if you wanted to see the data, you should have CMK. Okay, only the client application can unencrypt the data at the application tier. Okay, he can only do this because he has the CMK. In addition, the keys used to encrypt and unencrypt the data are not actually stored in SQL Server. I told you, right? The keys are not here on the SQL Server. Someone was asking me what is the difference between the regular column level encryption and always encrypted. Here, the keys are with SQL Server. All the keys are at DB level and at the instance level. But here, that is not the case. CMK is there on the client machine, so we don't know anything. Okay, the location of the keys owned by application owners is stored in SQL Server, but access to those keys is controlled by the application. Everything is being controlled by the application and also by CMK. So given that client application is the only place where decryption takes place, there is no way for us to build an index with always encrypted. That is the problem, guys. We cannot create indexes also with randomized encrypted columns, but with deterministic we can do it. Okay, we can do it, but it's very challenging even with deterministic. So what they have done is they have come up with certain technology called as enclave. What is enclave? Anyone knows the exact meaning in English for enclaves? Enclaves. Anyone knows that what is the meaning of enclaves? Not SQL Server, just plain English.
A territory?
I will show you. I need to talk about this part. I'm just showing you what is encrypted. That's it. Sorry, what is always encrypted enclaves and how difficult it is to implement. Let me go to the security. Okay, so I got these notes from this 2019 Bob Ward books. So why enclaves? So that is the question. Okay, why enclaves? So he's informing like this. Enclaves is nothing but he's saying some kind of foreign territory, a distinct territorial, cultural, or social unit enclosed within or as if with foreign territory. I didn't understand anything. Okay, forget about that. Enclaves, what it does is it creates a kind of buffer inside SQL Server where it can perform some actions on unencrypted data. Okay, so in short terms, I can say like this. What it is doing is enclave. So let's search for the right definition of enclave in English. Enclave meaning a portion of territory surrounded by a larger territory. Okay, a place or group that is different in character from this surrounding it. First part is correct. It's like you are creating one kind of environment for on the SQL Server side, and you are doing some kind of decryption at the SQL Server side. But to implement this, there are a lot many steps. First of all, this is related to hardware where they have released some kind of hardware for this, and even the steps are too daunting. We should enable blah blah blah. Rest of the things I don't know. Very difficult to implement. I thought of doing this, but I again understood for me to explain this, it will take a lot of time. So I am not doing this. The enclaves, what it does is it can see the unencrypted data on the server side. Inside this enclave, if you create that enclave, you can watch out that unencrypted data even on the server side. That is what I can say in simple terms. As I told you, the problem is you cannot see the unencrypted data even on the server side, SQL Server side, this side, server side, but you can see it from 2019, provided if you create this enclaves.
Looks like it is something like if you put the set of the data in enclave, so you can see that.
You can see that.
And out of the enclave, you can't see because this is
no, yeah.
This is encrypted.
The problem, as I told you, even SQL Server doesn't know anything about CMK. Okay, because the certificate is not there at this SQL Server side. So even if the data comes, it will be in encrypted format. So if you try to create index how can SQL Server can interpret the data? Because the data is not the regular data, right? It is encrypted format. And if you wanted to decrypt that, the key is not there with SQL Server. You cannot do anything. Always it knows about only this data. Let me show you. So if I say, if I remove this, okay, it's not there, right? Let me connect. And I don't think demo login one is having access. So I mean to say you will get that 0x something, 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 right? Even SQL Server knows only about that. It doesn't know anything about whether it is Steve Smith or Matthew McGiffin, something like that. It doesn't know. Since it doesn't know anything about the data, you cannot create the index on it. That is the problem. But when you are creating with Enclaves, so SQL Server is trying to get that unencrypted data. It can see that unencrypted data and then it can start working on it. So that is the advantage of Enclaves, and it is very, 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 very hard to explain that topic. So this is what I can say for the moment. So questions, why it is not going? Okay. Only 11 people today. So let me know if you have any questions. Did you understand, first of all, what is always encrypted? At least the basics. We don't need to have thorough knowledge on that.
Yeah.
So I was doing something. I will talk about that. If you are okay, I will go with the next topic. Even my SQL Server is not responding. It's not responding. I'll get some water and I'll come back. You connect with some other thing, and this is what happens. I think I have to kill this. Okay, done. Okay, the next topic, I wanted to show you some basics again on some new technology related to Azure SQL, and from 2019 it is there. 2017 also we have few things. How many of you are aware of this term? At least I'm talking about term, not about the technology. Intelligent query processing, IQP. Again, don't feel I'm showing you something very daunting. With the technology, you are going to you will be in a better position if you understand the technology properly. That's it. Intelligent query processing.
I heard that, but like I don't know about it.
Anyone else?
Yeah, I also heard about the term Somsi, but not gone into details.
Okay. That is somewhat important. So I will talk about IQP. It's called as intelligent query processing, and it is bound to Azure SQL also. That is why I'm talking about here on my mission for the moment. So then I will take this backup, not backup, I should say backpack, and then I will show it on Azure SQL. Okay, so what is IQP, why it came into picture, and what as a DBA we should be aware of. This is also very important topic, guys. And after seeing the demos, you will come to know like the importance of IQP. Okay, till now we have from until 2012 we have something called as indexes, right? Traditional indexes. All the indexes are row-based model, right? Rows is nothing but we have the B tree structure, and it stores the data in the pages, and all the pages has to have that will have that information. And if I'm retrieving the data, all the pages should be there inside my buffer cache, right? It is there till 2008. From 2012, Microsoft has come up with a new technology called as column store indexes. Heard about column store indexes? I think so. At least you know the name column store indexes. In 2012, when they introduced it, it was read-only, and also it is applicable only for non-clustered indexes. So entire table itself is becoming read-only there. I mean, not entire table, that column. It's just for read-only purpose. You cannot have the data inside that. You cannot update anything inside if you are on 2012. So column store technology, why it came into picture? What is the difference between column store indexes and our regular indexes? What are your thoughts on it, if anyone knows? Just give it a try, no problem. Oh, everyone is busy today. Okay. Column store indexes versus row store indexes. Okay, so if I take this two sections. Okay, so column store is the way it saves the data. The architecture of it is completely different from row store. So there are, if I open this, I don't have any diagram. Let's take one images. So this is how it looks. So row store, if I take, all will be in the format of rows. 1 product A 20, 2 product B 30, 3 product C 15. So this is in page 1 and page 2. If I make it as column store, all the information is now related to that particular column will be in one segment. We call it as segments. Okay, in column store we have something called as segments. In row store it's called as pages. Okay, just the way it is storing the data, it's completely different. Row store is different, column store is different. This is how it looks. In row store, all the data is inside my pages, whereas in column store, it will be inside my segments. And this is how it looks when you create column store indexes on that particular column, what you are doing. Okay, so there are few things here. I don't know how many of you are aware. So if you are not aware, I will just show you. And if it, I hope you will be able to understand. If not, you have to go with at least some basics of column store indexes. Okay, so from 2014, they introduced something called as writable column store indexes. From 2016, I guess they have introduced clustered column store indexes. Until 2014, it was non-clustered. There was no support for clustered for the column store, but from 2016 they have introduced clustered column store indexes also. The way it executes is completely different from row traditional indexes, the row mode. Okay, there is something called as batch mode. This is important, guys. So batch mode, batch means, because since the data is created all the data is inside one segment, so it operates on this entire segment as a one batch at one shot. Okay, so the way it operates the data on column store indexes, it's called as batch mode. Again, I'm repeating, batch mode for column store indexes, whereas for row store, it's called as row mode. So we have two terms, how the database engine gets the data from the tables. If you are having traditional row store, it will be row mode. If you are having column store indexes, it's called as batch mode. Did you get this difference? I'm not going deep dive. I'm just showing you a high level picture. Are you getting this or not?
Yes, yes.
So row store is row mode, whereas column store is batch mode, in simple terms. Okay, so that is what we have from 2012. I think from 2014 or 2012, because 2012 we have only read only. I think maybe from 2014 they introduced something called as batch mode. Batch mode is has been developed a lot from 2016. So we have the batch mode support because we have the clustered column store indexes from 2016. It was going well, that's fine. Again, they thought of doing some enhancements. So on 2017, they came up with few enhanced technologies, and from 2019 they increased this a lot, and now we have completely a different picture. So I will show you with the demos, and after that I will come back to theory part. It will be very interesting, guys, believe me. You will get to know so many things. So even I think I have written one article on my blog when I was in Planet 2 years back, I guess. Column store, I think 2019 is, let me search. I think this is the article. 2019, how SQL Server 2019 helped me in solving the performance issue. Okay, so I've written this article long time back, and this is related to the discussions what we are doing right now, the batch mode and row mode. Okay, so this was written long time back, but yeah, I will help you with the demos now first. So let me take this. So this is my instance. Of course, this is local laptop, but the topic remains the same even on Azure SQL, guys. I didn't export that backpack. Otherwise, I could have shown it directly on Azure SQL. But understand the concepts first. Okay, so imagine I have this database, wild word importers data warehouse database. So now what I am doing is I am setting the compatibility level to 150, and I'm clearing the cache, procedure cache only for that database. Instead of doing dbcc free proc cache, we can do it only on that particular database, right? So I'm just showing you the rows. I have these many rows. I don't know the count. We have something. So what I am doing is I'm fooling the SQL Server here. Okay, I'm fooling the SQL Server by saying update statistics table name with row count equal to 1000. Generally, how many rows I have? 3.7 million, I guess. If it is lakhs, it is 37 lakhs. If it is in million, it is 3.7 million. Okay, I have 3.7 million rows. And I am saying to SQL Server, okay, you are not having 3.7 million rows. You just have 1000 rows. Okay, you just have 1000 rows. That is how I'm fooling. You can do this if you wanted to practice fooling the SQL Server. Okay, don't do this on production. If you wanted to do it for testing purpose, it's okay. So by doing this, what I am doing, I am outdating the stats, right? Obviously, I'm outdating the stats here because now my table thinks, if SQL Server database engine thinks for fact.order history table, only 1000 rows are there. Okay, so that is the problem here. Okay, now see what happens. So I'm executing one query. This is the database. I'm executing facts order history with some table, and let's see what happens. Oh, I didn't turn on the execution plan, I believe. Let me check. So it is taking some time. Let's wait for it. It will take 1 minute or so, if I'm not wrong. Okay, still executing. It got completed now. It took 50 seconds for its completion. Okay, I will do it again, by this time by having the execution plan, and before that I will do the same thing. Okay, this time I will get the execution plan, because it's very important for you to understand few terms inside the execution plan. And that's the reason. It got completed. Now understand the important things here. I'm going to the execution plan. It took 49 seconds for our execution. And now if I go to the table scan, as I told you, I fooled the SQL Server. Just read the estimated number of rows. It is showing only 1000 rows, right? If you see, I cannot do it. How to get that? Can you see this estimated number of rows to be read?
Yes.
It is just showing 1000, whereas in reality, the number of rows read on the top is some 37 lakhs or 3.7 million. So I fooled the SQL Server. Now SQL Server is thinking that it has to get only 1000 rows since I fooled it. But since we fooled the SQL Server, it is not getting the right estimates here. Okay. So, and now coming to hash match, if you can see, my hash match is spilled to TempDB. As you can see over there, it's saying operator use TempDB to spill some pages. So 52,016 pages, right? So 52,016 pages means what will be the size? 52,016 pages into 8. So this is the exact amount. Means if I divide it by 1024, I will get in megabytes. So it is close to 400 megabytes. So 400 megabytes of data has been spilled to TempDB. Why it's spilled to TempDB? Because SQL Server thought it's only 1000 rows, but in reality it is 3.7 million. If I go to this select here, and if I go to the properties, we have something very important called as memory grant info. You can see this, right? So SQL Server has requested only 1 MB of memory. So desired memory is nothing but whatever SQL wants. So SQL Server is thinking it just needs 1 MB of memory, and it has granted 1 MB of memory. But in reality, it is asking nearly 400 for this query. We should, to avoid the TempDB spilling, it has to have at least 400 MB. But it didn't ask for 400 MB. We just requested 1 MB, not we. Database engine thought 1 MB is good enough. And if you see here, there is one very, very important field called as is memory grant feedback adjusted. I'll talk about this. So what is the result of this? It is showing no first execution. Keep that in your mind. Is memory grant feedback adjusted? It is showing as no first execution. So now you understood the problem. SQL Server, because of having outdated statistics, it has requested only 1 MB of memory, but in reality, because it has so many pages, it has provided only less memory for this query. Query grant for this query, memory grant for that query. So that is a problem. So it has spilled down to TempDB. So as you can see, it has nearly spilled down 52,000 pages, which is close to 400 megabytes. Okay, so 400 megabytes of activity has been spilled to TempDB. So you will come to know, right? In TempDB, it gets full very fastly. If I execute this query, imagine if I execute this query from 10 different clients, say 1000 times, just imagine how fastly this will eat up the TempDB. Is it right or not? So 400 MB. So if I say, if I'm having 400 MB, and if I do this constantly from different apps or different servers, so definitely my TempDB will be eaten up very quickly, right? So now if I execute the same query without doing any modifications second time, second time. So first time it took 49 seconds. Let's execute this for the second time and see what happens. If by any chance, if it repeats the same value, same number of time, I mean, same one megabyte, the same thing, then we have to execute it again. Then I will talk about that, because sometimes SQL Server is not able to get that thing. So I will execute that one more time. You will come to know. I think it is not able to. Let's wait for it. "49 seconds, right?" So same thing, 49:51 seconds. So that means it is still estimating the same 1000 rows, same thing, and it is spilling out to disk. And if I go to the select, which is the important thing I wanted to talk about. So if I go to the memory grant info, again, it is showing the same thing, 1424 means 1 MB, 1 MB, no first execution. Okay. So let me execute this one more time. You will get to know the importance of it. Okay, now the results are super fast. So it has come up in 3 seconds. Did I add any index? Did I do anything? I didn't do anything. I didn't add any index. I didn't do anything. All of a sudden, my query from 49 seconds or 51 seconds, it has come down to 3 seconds. Okay, and now if I go to the execution plan, that warning is not there. So it didn't spill to TempDB. Okay, and if I go to the select operator, and if I go to the properties, so watch out this guy very carefully. Memory grant info from 1 MB, now it is requesting 625 MB. Okay, so since it has requested the right amount of memory, my query didn't spill to TempDB. Okay, and now see this field, is memory grant feedback adjusted? Yes, adjusting. For the first time when it executed, it doesn't know anything. Okay, so IQP is nothing but intelligent query processing. Okay, we'll talk about that. And as part of IQP, we have something called as allocation of memory, query grants. Okay, query grants. So this is very important. If you wanted to understand, this is the right example. When I execute the query for the first time, SQL Server doesn't know how many pages or how much grant it has to provide for this query. Okay, it is blank. So it thought it has only 1000 rows. So it has given only 1 MB for this query, right? So since it has granted 1 MB, but the work it has to do is quite a lot, because 1000 rows versus 37 lakhs is completely different. So it's spilled down to TempDB. Okay, so we have the hash match and all the operators. Hash match is nothing but it has to create the probe table. So all this work will be done internally on inside the TempDB. So it has spilled down to TempDB, and it required 400 MB of memory. 400 MB space on the TempDB. Okay, so after executing this query for the second time without making any changes, I didn't make any changes to the stats. I didn't make any changes. Even now, if you see, if I go to the table scan, it's same 1000 number of rows. SQL Server is still estimating 1000 number of rows, but in reality, it has 37 lakhs. But if I go to the select operator, all of a sudden, instead of 1 MB, SQL Server is now requesting 625 MB. It is requesting the right amount of memory for this query, and memory grant feedback is getting adjusted automatically. Okay, that's the beauty of 2019 or Azure SQL or Azure MI. The same query without making any modifications for the second time, it will get the right amount of memory grants for the query. This is the beauty of it, and this is what you should know. Memory grant feedback, it's getting adjusted automatically when you execute it for the second time. Got it or not? Is it not interesting? I don't know. Like, I felt it very interesting to be.
Yes, it's good. And mostly this column store index is widely used in OLAP environment, right?
OLAP, but now we can use it in OLTP also.
Yes, I
it's
see.
very much possible. And even if you see here, fact order history, let me show you my fact order history table. SP Blitz index fact dot. Okay, we have. Okay, I will go with the detailed information. Schema. Because if I use SP help index, it's not clear. So that's why I'm using this one. Table name, order history. Order history, I think somewhere I'm not given properly. Let me run this. Okay, as you can see, these are my indexes on that order history table. Okay, and am I having any column store indexes here? It's all traditional indexes. I don't have any column store indexes. So as I told you, that is the difference between 2017 and 2019. So until 2017, this batch mode executions were only applicable for column store indexes only. On the columns where we have column store indexes, batch mode execution comes into picture. But from 2019, irrespective of whether it is column store or row store mode, so we have batch execution comes into picture even for row store retrieval as well. That is the beauty of 2019. From 2019, we have this, and let me show you that part. So you can see as of now, the storage is row store here. You can see that, right? And 1, 2, 3, 4, 5. Storage.
Yes.
Under the storage section, you can see that whether we are going with batch mode or row store mode. So as of now, it is going with row store mode. Tomorrow, I'll show you with the demos on batch mode and this row store. But today, I wanted to show this on memory grant thing. Okay. So from 2019, we have the support for batch mode even on traditional indexes also. So as of now, I don't have any column store indexes for my table, but still the memory grant has been adjusted. Only difference on 2017 and 2019 is 2017, it can go to batch mode only for column store indexes, but on 2019, it can go for batch mode even though your table is traditional, I mean row store. Okay, so this is called as batch mode on row store, which is there only from 2019. Okay, not in the previous versions. That is one thing. So now, since it has underestimated because my stats are outdated, I intentionally did that. Even though it has underestimated, for the second time, the memory has been adjusted accordingly. Okay, that is the beauty of memory adjustments in SQL Server if you are on latest technologies, latest versions like 2019 or Azure SQL or Azure MI. So that's the beauty of it. So you have to understand, because if this query gets executed for the first time, imagine this is a very big query and it is spilling to 10 dB. You think that, okay, something is happening with the query. But if the same query gets executed for the second time, you need not do anything. You need not do anything because SQL Server will itself adjust the memory correctly for that query. It's called as memory grant. That memory grants will be adjusted automatically. That is the excellent part of SQL on the latest versions. I don't know about 2022. I didn't read that. I'm still at 2019. But I think perhaps they might have increased. I mean, they might have done a lot of work on 2022. Maybe we might have got few more enhancements. I'm not sure. But this is about Azure SQL and Azure 2019. Same thing, if you execute the query on Azure SQL also, it remains the same. Okay, so since we underestimated, this is the problem. So what if I overestimated? Will it work accordingly or will it not? What is your opinion? Since we underestimated. So yeah,
It should work.
so now what I will do is I will do one thing. So I will update this first with proper count. Sorry. I've shown you for underestimation. Now let's see for overestimation. So let me show this. So I am saying SQL Server that it has these many rows. I don't know, maybe 500 million, billion, I don't know the numbers. So I am overestimating the number of rows. In reality, we have only 37 lakhs, but we are doing some kind of overestimation. So let me switch on to that database. We're done. Now, what I'm doing is I'm executing stress to generate some load. Okay, so that you will see how the estimation is happening and what's happening behind the scenes. Okay, so this is stress tool where I can do some kind of things like this. Okay, so I'm running this query. Let me run this query. And if you see here, let me show you SP who is active. Since it is overestimating, what will be the weight type? Okay, see these weight types, resource semaphore. All the weight types are on now resource semaphore because it is overestimating the memory. And my SQL Server, if it is getting overestimated, I will get resource semaphore weights. Underestimated, 10 dB sucks. Overestimation, resource semaphore comes into picture. This is the problem. That is the importance of statistics, guys. Now you understood, right? If my stats are not up to date, SQL Server literally will cry with this kind of problems. Wait for it, because I think I ran 10 threads at the same time. So it will take some time. I think it is 10. Yeah, 10 threads. So wait for it. So as you can clearly see, this is overestimating problem, and that is why you are seeing resource semaphore. Wait for this to get completed, and I will show you how to, I mean, not me, how SQL Server will overcome that problem automatically. It's in execution now. It's done. So it is now done. If I go to SP who is active, nothing will be there because everything is finished. And now if I execute the same query, I will show you how SQL Server thought the estimation of memory. Okay, if I go to the select, did I clear the procedure cache?
No.
I think I didn't clear the procedure cache. That might be a problem. Okay, let's check that. Properties and memory grant info. Okay. Oh my goodness. So this is estimating. What is the number? I think it is 1 terabyte. This is in KBs, guys. So if I remove 3 figures, this is MB, not this one. This is MB. This is GB. So 1 terabyte. So SQL Server is expecting 1 terabyte for this query, and it has given 3.7 GB of memory. That is why you are seeing resource semaphore bytes, because it has been granted 3.7 gigabytes of memory, whereas actually what is that it used? It used only 535 MB. It has to use only 535 MB, but it has granted me 3.7 gigabytes of memory, and it is actually expecting 1 terabyte. That is the problem. Okay, if I execute the same query again for the second time, let me remove all this stuff. And sometimes it is not picking at the very next moment. You have to execute it one more time. I'm sorry for that, but that is how it is working. So let's check this now. I didn't clear the procedure cache. I'll do that. Let me clear the procedure cache. And also I have to turn this option off. I think I did this. I think I did this procedure cache. It is there. Anyways, I will do it one more time. Okay, so now you got that problem, right? Now, if I execute this query, where is that guy? Overestimation, you can see that now. Now, if I turn these options back, these were turned off. Okay, now I'm turning these options back on. Row mode memory grant feedback, batch mode memory grant feedback. I am turning these options on. After turning this on, and if I execute this query, let's see what happens. It will fix this automatically. Just wait for it. I will execute it second time because we just turned it on. I forgot to turn it on last time. One more time. Let's check. Hopefully it should have fixed. Memory grant info. Okay, see, now it has come down to 820 megabytes from 1 terabyte. Okay, from 1 terabyte, it has come down to 820 megabytes. Of course, if you calculate this, this is 802 MB. Okay, now as you can see, is memory grant feedback adjusted? Yes, it is adjusting automatically, and it is using 534 MB. So that is the beauty. Okay, if I run the same query now with stress, okay, and if I watch out for SP who is active, you will not see that resource semaphore waits. Let's wait for it because I didn't turn on the password. For the first time you will see, but resource semaphore waits was there right from the picture, but after some time this will not appear, guys. Wait for it. I'm getting a call. You got the point, right? How the memory is getting adjusted automatically. See, now it turned into null. It's still in progress. It's still in progress. Okay. Previously, for the entire query execution, the weight stats were resource semaphore. Now it is not the case. Initially, it took some time, but now it's showing null. All the queries are executing without any resource semaphore weights. That's the beauty. Any questions? 1 second. Just give me a second, guys. Okay. Okay. Any questions? How the memory of SQL Server has been adjusted automatically with these two options, memory row mode, memory grant feedback, and batch mode memory grant feedback. It will be on by default. For the purpose of these demos, I turned it off to show you what the problem is. I know it's a bit of advanced, but
this is called intelligence query.
Yeah, this is intelligent query processing. It falls into memory section because memory of the SQL Server is intelligent enough. For the first time, it doesn't know. It's quite blind. Once it goes into the cache, for the second time, if you ask the same query, if you execute the same query, SQL Server is now adjusting the memory accordingly based on the needs, means the right amount of memory. Okay, as you can see here, first time it imagined 1 terabyte of memory, right? Second time, it adjusted itself to 820 megabytes automatically. So that's the reason you are seeing yes, adjusting. Okay. And if you are estimating less number of rows, like the first example where I just thought only 1,000 rows are there. So it has given only 1 MB of memory, but in reality, it requires 420 MB of memory, but it didn't give, it just has provided 1 MB. So it's spilled down to 10 dB. In the second execution, automatically, I didn't create any indexes, nothing. I didn't update the stats. Automatically, SQL Server has adjusted itself to provide the right amount of memory. So that's the importance of or advantages if you are running on latest versions with respect to memory grant feedback.
So anyway, like the issue won't come to us like mostly like because the SQL Server will solve the problem.
Because SQL Server is solving the problem, you don't know, but that's why I'm saying if you execute the same query in 2017 or 2016, you will literally feel the heat.
Yeah.
Okay, if you are on latest versions, yes, you are lucky enough. But if you are on lower versions, that's why I said, that's why I have written this article, how SQL Server helped me. 2019 helped me in solving the performance issue. Why I am saying 2019 helped me? Because on lower versions, it was not the case. That memory grant feedback, nothing is there. Okay, that query was executed only for the first time. And even when it was executing for the second time on lower versions, it is taking a lot of memory. I mean, underestimation of memory or overestimation of memory. That problem was there. But when I shifted this to 2019, when I changed the cardinality estimated to 150, all those options, row store, that whatever these two options, it were on. Okay, and at the very next moment, that problem is disappeared. That problem got disappeared. Okay, so this is about memory grant feedback on latest versions. This is applicable for Azure SQL, guys. Unfortunately, I have done this on my local laptop, but the concept remains exactly the same. There will not be any difference. Okay, so that is about memory grant feedback. IQP, it's part of IQP.
Vamsi, that 820 MB, it's memory or MDB space?
MDB, actually, what is happening? If I will just correlate this stuff. In olden days, what will be our entire RAM? Like desktop, when we have 64 MB, 256 MB, 128 MB, right? Those are very low because memory was very costly in those days. So we were just having 128. If someone is having 128 MB of RAM or 256 MB, it's like crazy thing. But still, we were able to operate all the programs. We were playing games. We were listening to music. We were watching videos. We were mailing. Everything we are doing. How we are able to do all those things? Do you think that memory can accommodate all the stuff? No, right? So that is where operating system is making use of paging. Okay, paging or segmentation. That concept is called as paging. Means it is using your some part of space on the disk to act like virtual memory. Okay, so that is nothing but you are swapping the pages from memory to disk and from disk to memory. So that is how we are able to do all the things, even though we are having less amount of RAM in olden days. Similar technology is nothing but TempDB. TempDB, what it is doing, we cannot give all the memory whatever SQL is requesting, right? I cannot give. So what it has to do, it has to use some temporary space. That temporary space is nothing but TempDB, and it is throwing the pages from, if it is not able to allocate that entire memory, it is using TempDB as a temporary storage, and it is dumping the data onto TempDB. And if you are adjusting it, it will not use TempDB, because if you get the right amount of memory, SQL Server can adjust itself from 2019 and you will get the right memory. So TempDB is nothing but paging, that paging concept inside the OS. Exactly same. We can correlate that. Paging concept in OS is TempDB concept in SQL Server. Okay, so I think I'm done. If you have any
Vamsi, I have one question.
questions,
If you go and if you have enabled two configurations, can you go to that page, that memory grant?
yeah.
So this is only available in SQL 2019.
2019, yeah.
And this we need to do for any databases.
No,
which
by default, this will be
it
turned
is
on.
on.
It is on.
Okay, okay, great.
By default, it is on. You don't need to worry about that part. It will take care.
Yes, okay.
That's
Thank you.
why people wants to go with latest technologies, because there are so many things that comes which we are not at all aware, right? Are you people aware of this one? No, right?
No.
So
No.
very simple thing, but most of us, we are not aware because we didn't explore this topic. We think, okay, IQP means it's something very difficult, different, or difficult, whatever it is. We don't know about that. But in reality, this is not something very different. It's very easy. Just we have to come up with right approach to understand this. Okay. So
Vamsi,
yeah.
once it is adjusted, can we do it off again? So
yeah,
it will
you run it any number of times.
no.
Yeah.
You said first now it is on, right?
Yeah.
Now if we make it off again, it will be same
problem. Same problem. So if I turn this off, again it doesn't know.
So it won't use existing plan, you mean to say?
No, actually I'm clearing the procedure cache here, right? So okay, since I have to show the demo, I'm doing this, but in reality, if that plan exists in SQL Server, it will work. But if for some reason, if our system is having too many queries, if your system gets overloaded, definitely that plan has to come out from procedure cache, right? SQL Server itself will, you make use of lazy writer and checkpoint. It will throw your plan, particular plan for that query from the procedure cache. Once it gets flushed out from procedure cache, you will get that problem again. As long as it is there in the procedure cache, you are safe.
Okay.
Once you are done, it's gone. So I cannot replicate that situation, right? I mean, I cannot generate that workload. So I'm clearing the procedure cache to show that problem.
Okay. See, if TempDB is limited, what will be the weight? What is the weight we'll get? Page la chahiye or
if you are spilling that onto TempDB, what will be the weight type, right? That is what you are asking.
Yes.
So it is throwing onto disk, right? So obviously it will be page evaluate. If it is select, it will be shared. If it is insert, update, delete, it will be page evaluate _ exclusive.
Thanks.
I don't know like why people has not turned up, but I really felt today's class is very useful. Like the things which are there, but we are not aware. Anyways, I will request them at least to watch the recorded session. Thanks, Jaim. You helped me. Thanks for saving my day. Okay.
Okay, Vamsi, thank you very much. Thanks a lot.
So tomorrow I will try to show something interesting, like same thing, new topics on Azure SQL.
What is that?
Probably automatic tuning.
Okay.
With demos only. So everything will be with demos. So don't worry about demos.
Did you take the class yesterday?
Automatic tuning on that portal side?
Automatic tuning, yeah, it's there on the portal side, right?
Portal side, yeah, okay.
So that option is there. Let me just quickly show you. Just give a glance so that you'll feel a little comfortable. This option, automatic tuning. So by default, it is showing some options, right? Desired state, current state, all these things. So we'll talk about what happens if I turn it off and what if I do server, Azure defaults, everything. Okay.
Okay. Perfect. Thank you, Vamsi.
So
Thank you.
if it is possible, then query store also.
Query store comes into picture here only. You will automatically get to know about query store also as part of these classes.
Okay.
These 4 options you will come to know about query store also.
Okay.
Okay, guys. Thanks for your time.
Thank
Catch you
you.
tomorrow.
Thank you.
Yeah. Bye-bye.
Good.